two-step equations. As you can see that I'm employing this scale here that will hopefully give us just an idea of what exactly we're accomplishing here. Remember that solve means find the value for the variable. In this case, in this first example I have here, the value of x that makes the equation true. You can think of an equation as a scale that is balanced. As long as it's equals, it's balanced. We're trying to find out, you know, these x's that I have here are some unknown number of these green positive ones. So, looks to be like, I don't know, they could be 4 or 5 of them, but you shouldn't think of it as any specific amount. This is what we're going to determine when and the amount could actually be a negative number as well, but we'll see what that is here. So when we're solving two-step equations, what we want to first do is isolate the term with the variable, and in this case, that's the 3x. So if we want to get 3x by itself, we're going to need to subtract 5 ones from each side. So I'm going to do that. I'll show that here first. Subtract 5. We always want to do that first before we deal with the 3x. So that's what that's going to look like there. And you can see when I remove these 5, I'll just slide them down below here. And if I had a real scale, the other side would now be heavier, and this would be tilting. This side would be, the side I'm removing from would be tilting upwards, but it's not a real scale. It's just a picture of scale. So I'm going to have to remove 5 on this side as well. So that's 2, 3, 4, and 5. Okay? So now, as you can see, an equation would tell me, visually, 3x equals 6, and it certainly is apparent in the algebra we're doing here as well. So 3x equals 6. Now, what I can't do here is just kind of subtract this 3 away. This is 3 times x. What I really want, the way I'm going to get home with this one, when I get down to 1x, is I can't subtract, nor could I subtract 2x here, because I don't have any 2x over here to subtract. What I can do here to get to what 1x is just say I'm gonna need to multiply each side by the reciprocal of 3. In other words, take 1/3 of this 3x. But again, if I'm taking 1/3 of this left side, I've got to take 1/3 of the right side. So when I'm taking 1/3, what I have, so basically what I'm saying, I'm not going to have anything else. So if I'm keeping 1/3, that's one way you can think. I want to keep 1/3 of each side. So I'm going to eliminate these two because I took 1/3 of that side, and what remains is 1x. I took 1/3 of this side, and what will remain is 2. And so we have now considered ourselves having solved this equation. We do need to check it. I think we're pretty sure that we were successful here. But so we slide down, use the same procedure. Remember, we have to check the original equation. We don't want to check like a partially solved equation. So we're going to put 2 in for x, add it to 5, put our question mark over our equal sign. Does 6 plus 5 equal 11? 11 equals 11, so that checks out. So now we'll circle our solution, provided that we have confirmed that with the check. Okay, so let's talk about when we see, so how we're going to deal in this problem. We have 18 minus 2x equals -4. So I have all these ones here, that's the 18. The way I'm going to show minus 2x, I'm going to show 2 negative x's. So it's essentially the same thing as a positive x, except the negative would mean I owe it to somebody. So on this scale, these 2 negative x's plus these 18 positive ones equal these 4 negative ones. So how am I going to find out So in this, I'm not solving for negative x here. I'm solving for positive x. So the way I'm going to do that, somewhere along the line, I need to multiply by a negative so that I can turn these a different color and get these negatives, and I'll make sure we have a positive x there. So again, I'm going to isolate the term with the variable in it right here. So I want to get this, including the sign, by itself. So what I'm going to do is subtract 18 from each side. And that's the same, and I have 18 ones to subtract here, but what you can think of this subtracting 18, remember when we can always think of subtraction as adding a negative, so easy enough on this left side, we can just get rid of these, we can just get rid of these 18. I'm going to have to do this like so. I'll bring these back down. So I got rid of those 18. Now, I don't have 18 positive ones to get rid of on the left side, but remember, subtracting a positive is the same as adding a negative. So negative 4, so my point is here, that negative 4 minus 18 is the same as negative 4 plus negative 18. So what I really have to do here is add 18 of these. Now I don't have those here handy, but what I'm gonna do is just move this over a little bit and just clone these really fast. And it'll let me do that if I move the scale surface, these are over here. So I'm gonna take these 4 and I'll put them back in a second, but for now I've got to clone these. Alright, now I can move these over for a second. Okay, so I'll move these, whoops. So these are back on the scale. Let me just clone these. So that's 4. I'm going to need to do that. I need 18 of these, right? So clone, 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 and then I just need a couple. To clone this twice. And that will bring me up to 18, I think. Okay. So there's, just do this in sixes. It's a little tedious, but it gives us a good view of things. Okay. And then if I do that in sixes, I gotta get 3 more there. So let me get 1 more, and let's see, what do I have left? Okay, looks like I got 1 too many here. Okay, so I guess if I can add these 6, I've now got them all here. Just assume those all are fitting from the scale. Now, so what do I have at this point? What I have at this point is, I'll just move my work over to here, since I had to move things around. So so when I have this, I have negative 4 minus 18, that's negative 22. So I have negative 2x equals negative 22. Now the way I'm going to, I only want one of these negative x's, and I need to turn it positive. The way I can turn it positive is, well, I need to multiply it by negative, and since I only want one of these negative 2x's, I'm going to multiply it by negative, I'm going to multiply by a half. So negative turns the color of it back to a yellow, which is what I want to do. And so I end up here with, the math would tell me 2 negatives make a positive, half of 22 is 11, so it would tell me that I have 11 positives, all right? So I took half of these, so I really need to remove 11 of these. I can do that, I think, fairly quickly. Actually, if I remove, I think that's 11 right there. If I multiply 1 or 2, I think you'll understand, because there's a lot of numbers here. So let's see if this equals 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I actually was one short on here with one of those sets of 6. So there should be 11 still there. I've got 2x equals 11 now. Both of these are going to get made positive. Actually, one of these is away because I took half of that. So we get negative x equals 11. This should actually be positive. I'll turn it to yellow. So x equals there, and the greens. And these all need to turn green because they're positive. And okay, actually that's my background fill. Let me get rid of that. Didn't do that. So these have got to all be positive. And let's see if I can make that happen. There you go. Look, I missed a couple. Change these two. I'll just exchange these two for these two over here. So, and this negative no longer exists, so I'm just going to see if I can take this out of there. No, I can't, so I'm just going to scribble this with a little yellow, just so I don't confuse anything. So that's x equals 11. Now I can check this. So I can check this. Again, I got to plug into the original equation. And that's 18 minus 2 times 11. Does that equal, the original equation was negative 4. This is 18 minus 22. Fix the question mark here. You can see negative 4 equals negative 4, so that is a good solution. Right. So, I think that's enough with the only thing I want to show you in this next one is I'm going to do the work without the manipulatives because that's really slightly dull. I want you to realize that this 1/2 x could be displayed this way, like a half full version of x, and then I've got 7 negatives, that's this minus 7, I've got these negative 4. So this is what we're dealing with, but we're trying to find out what all of x is, so with that quantity filled there. So again, we're going to isolate this term with the variable, so isolate this, and you get negative 4. So what I'm going to do with that is I'm going to add 7 to both sides. So negative 4 plus 7 is 3, and I have that all equal to 1/2 x. But I don't want to know 1/2 x, I want all of x. So I'm going to need to double that. So rewrite it down here. Double that side, and if I do that, I've got to double this side, and I get that x equals 6. And before I do that, I'll check it. Before I circle what that is, I'll check it. So if negative 4, does that equal 1/2 x? Actually, not x, let's go ahead and plug the value in there. Times 6 and minus 7, so negative 4. Does that equal 3 minus 7? And indeed it does. Negative 4 equals negative 4, so that checks out. And we'll circle our solution. Okay, let's try one more. This one's negative 5x plus negative 9 or minus 9 equals 21. So on this one, I'm going to need to add 9 to both sides. I get negative 5x equals 30. So on this one, I've got to change, I've got to do 1/5 of this negative 5x, and I need to turn it the other color, so I need to multiply it by negative. So multiply by negative 1/5, multiply by negative 1/5, and I get x equals negative 6. Let me check it. Negative 5 times negative 6 minus 9, does that equal 21? That's negative 30 minus 9. I'm sorry, that's positive 30 minus 9. That does, you can see that is going to equal 21. So that checks, and then I can circle this. All right, let's look how to model a couple of word problems, because after all, the reason why we're learning all this. So in this problem, you have 4 friends that are playing golf. The total cost of a round of golf is $108. Each person has the same coupon. The total cost of the round with the coupon is 76. So how much is each coupon worth? So again, you could do this without algebra. Once again, we're going to kind of force the issue a little bit with some algebra. Let x equal, let me use c so we can remember what it is we're looking for here. Let's c equal the dollar value of each coupon. Now in this one, so what you have here is, one way you could set this one up such that you had to solve a two-step equation. You'd say, well, 108 minus 4 times what each coupon's valued at would equal what they ended up paying. They would have paid 108, but if they subtract 4 times what each person turned in terms of a coupon, we need to figure out what value that is such that the result would be $76. So we're going to isolate this term. Now when we isolate this term, note that we want to isolate it with, we can't just pretend this negative doesn't exist, so that's going to come down for the ride. So what we have here, so 108 minus 76 is, so we got negative, so that's 24 and 8, so that's 32, so equals negative 32, right? Then I've got to, I want to get what positive c is, so we multiply both sides by negative 1/4, and I end up here getting c equals $8. So each coupon was worth $8. One more. So let's say a school makes $715 from ticket sales for a school play. From the ticket sales, $448 was from adult sales. Student tickets are $3 each. How many students attended the play? So let's, in this one, let's let, I like to use S's, so I'm going to just use X this time. I don't like to use S's or T's. Let X equal the number of student tickets. We're going to say who attended. Alright, each student's ticket is costing $3. And what we know is that the adult ticket sales, not per ticket, but each ticket, the total number of adult ticket sales, this is student ticket sales plus adult ticket sales equals this total money brought in from the adult and student tickets of $715. So I want to subtract 448 from each side. And that's 267 equals 3x. And I multiply it by 1/3 on each side. So 267 divided by 3, that's what that's going to come to, is 8. 24, 27, so that's going to be 89. So there were 89 students that attended the play. And okay, so that should be enough information to serve you well on homework. Thanks for listening and watching.